In last class, we have seen data types and measurement scales. Today, we will see descriptive analytics. Descriptive analytics represents complex data in user-friendly manner. Descriptive analytics are important to extract important information from raw data. Descriptive analytics help to identify what had happened in the past and to understand business well. Descriptive analysis can be performed by using following techniques: data cleaning, data summarization, and data visualization. Data collected from different sources may not be in proper format. For example, while collecting our exam registration data, some students will retain their branch as CSE. Some of them write computer science and engineering. Both are same. While reporting, we don't know how to relate them each other. So we need to take care of such kind of things by cleaning raw data. If some missing data is present in your dataset, you have to replace that data with the proper values. To do that, we need to know data types and measurement scales. We already discussed that in our previous class. We are not going to discuss the data cleaning part because you already done this thing in your data mining course. So I'm not going to discuss this part. Second one, summarization of data. Summarization of data can be done by using descriptive statistics. To understand this, suppose you are dealing with big data. If someone wants to go through a raw data, it is waste of time. So we need to have some values which can represent our data and can be understood easily. So we need some measures which can describe data. This can be done by using descriptive statistics. Descriptive statistics are measures which organizes information into something that is much more usable. These three, distribution, central tendency, and dispersion, are used to summarize data in descriptive statistics. Let's see each one detailed. Distribution. The distribution is a summary of frequency of individual values or a range of values for a variable. For example, the frequency distribution of each response to a survey question is depicted here. That is the rating question. 20 respondents marked with strongly agree, 30 respondents marked with agree somewhat, 20 respondents not sure, and 15 respondents disagree somewhat, and 15 respondents strongly disagree. Means this is the frequency distribution of each response. Means strongly agree and agree somewhat, not sure, disagree somewhat, strongly disagree. Central tendency. Central tendency of distribution is an estimate of the center of a distribution of values. There are three major types of estimation of central tendency are mean, median, and mode. Mean is the arithmetical average of the data. It is probably the most commonly used method for describing central tendency. Assume that the data has small n observations in sample. Let xi be the value of ith observation. Then mean can be written like this. Sample mean x bar equal to sum of all observations by number of observations. This can also be written like this. Summation from 1 to n xi by small n. Here x bar is sample mean. One important property of the mean is summation of deviations of observations from mean is 0. If you add deviations of observations from mean will be 0. We will use this property in some proofs. Remember this. If entire population is available, then mean can be expressed like this. Population mean will be denoted by using mu, sum of the observations in the population by number of observations in the population. It is summation from 1 to n xi by total number of observations in population. Mean is a phenomena called wisdom of crowd. A collective wisdom of people is better than any individual person's knowledge. If data is captured in frequencies, then average could be expressed like this: x bar equal to summation from 1 to n frequency of each item multiplied with its value by summation of all frequencies. Mean is affected significantly by presence of outliers. Suppose if you want to know average income of employees in some organization, to do that you take sample of 15 employees and you want to calculate the average income for that 15 employees. One of them is company CEO. He might be the billionaire like Mukesh Ambani. Then average is not true representative of the group because mean will significantly change by the salary of that billionaire. This is far from the all other employees. So if outliers are present in the data, mean cannot be a good measure of central tendency. It is not median. Mean is good when data is continuous, numeric, and distribution of data is symmetric. Second one, median. The median is the score found at the exact middle of the set of values. To find the median, first we need to sort the numbers in ascending or descending order. If number of observations in data is odd, then median will be n plus 1 by 2 value. If n is even, median will be at the position average of n plus 1 by 2 plus n plus 2 by 2. Median is stable than mean. Adding new observation may not change the median significantly like mean. When observations are skewed, median is very good measure of central tendency. Means if outliers are there, means CEO salary far from the all other employee salaries, then frequency here it will be high and here it is low. In this kind of situations, median will be a good measure of central tendency. Data is ordinal and distribution of data is skewed, then median will be the good measure of central tendency. Drawback of median is it is not calculated using entire data like in case of mean. Third one, mode. Mode is the most frequently occurring value in the set of scores. To determine the mode, we have to count frequency of each value. The most frequently occurring value will be the mode. For example, 10, 20, 30, 20, 30, 20 is our data. Then 20 is repeated 3 times, which is the maximum of all. So 20 is the mode. Mode is the only measure of central tendency which is valid for qualitative or nominal data. Other measure of central tendencies are percentile, decile, and quartile. These are used to identify the position of the observation within the dataset. Percentile, it is denoted as a p of x, is the value of the data at which x% of data lie below the value. To find p of x, we have to arrange the data in ascending order, and the value of p of x is the position corresponding to p of x will be x into n plus 1 by 100. Here n is the number of observations. Decile, it is a special value of percentile that divides the data into 10 equal parts, whereas in percentile it will divide into 100 equal parts. First decile contains first 10% of data. First decile can be found by using this formula. P of 10 will be 10 into n plus 1 by 100. Second decile contains first 20% of data. This can be found by using this formula. Quartile, it divides the data into 4 equal parts. First quartile, represented as Q1, contains first 25% of data. Second quartile, Q2, contains first 50% of the data, and it is also median. Third quartile, Q3, contains first 75% of data. Formula for first quartile, it is same as P25. So 25 into n plus 1 by 100. For quartile 2, it is equal to P50. So 50 into n plus 1 by 100. Like that, Q3 will be equal to P75. Measure of central tendency will not alone sufficient to understand the data properly. Suppose if our HOD ma'am asks how students are performing in particular subject, then if I give the average marks of students in that particular subject 70, it doesn't mean all students are performing well. To know that, we need other measures, that is measure of spread, also called as measure of variation. Dispersion refers to the spread of the values around the central tendency. Most common metrics to measure variation in the data are range, interquartile range, standard deviation, and variance. Range is a difference between maximum and minimum values of the data. It captures the data spread. If our data is this one, then maximum value is 90 and minimum value is 10. So you have to calculate range by subtracting minimum value from the maximum value. It is 80. Interquartile range. Interquartile range is a measure of distance between quartile 1 and quartile 3. It captures the spread of data. For example, the temperature for a city over a week are 35, 23, 28, 25, 28, 32 and 33 degrees. To calculate the quartiles, sort the data. Means you have to arrange the data in increasing order. Then first quartile will be P25. So 25 into n plus 1 by 100. 25 number of observations here 7. So 7 plus 1 by 100. 8 by 4 it is 2. So first quartile will be the value at position 2, that is 25. Q3 will be P75, that is 6. Q3 will be the value at the position 6, that is 33. Interquartile range will be the distance between quartile 3 and quartile 1. Then that is 33 minus 25 in this example, that is 8. If data is numerical and its distribution is skewed, then interquartile range will be the good measure of variation. We can use interquartile range to identify the values that are much far from the center than usual. Interquartile range tells us how far a typical value could be from the average. So anything much more than typical distance can be identified by using IQR. Interquartile range can be used to identify the outliers. Suppose this is the math score, and this is reading score, and this is writing score. Here most of the data will be within the interquartile range. If any data that is far from this interquartile range will be treated as outlier. The lower bound, it is Q1 minus 1.5 into interquartile range value. Here this is the lower bound. All the values below this lower bound are treated as outliers, and all the values above this upper bound will be calculated by using Q3 plus 1.5 into IQR, will be treated as outliers. Variance is the measure of variability in the data from the mean value. Formula for variance is, for the sample, it is small s square equal to summation from 1 to n xi minus sample mean whole square by n minus 1. The variation of population, sigma square equal to summation from 1 to n xi minus population mean, that is mu whole square by n. Standard deviation is the square root value of variation. The formula for population standard deviation is sigma equal to under root of summation from 1 to n xi minus mu whole square by n, and sample standard deviation s is this one. If data is numeric and have the symmetric distribution, then the standard deviation or variance is the good measure of variance. Data visualization goes further, taking the data and creating a visual that instantly communicates a story. Example, pie charts, line graphs, scatter plots, box plots, bar chart, and histograms. Through data visualization, it is easier to find patterns and identify how various data points related to each other. We already covered this topic in our data mining lab, so I am not going to discuss this topic now. Let's see simple example for descriptive analytics. This dataset is taken from the Kaggle. This kernel is also taken from some Kaggle notebooks. See here, this dataset contains students' scores in maths, reading test and writing test, and some of their personal information like gender, ethnicity, parent level of education. These are the summary statistics used to summarize the data. Means what is the mean value, what is the standard deviation. Here math score standard deviation is 15, and reading score standard deviation 14, and writing score standard deviation 15. Like that you have minimum, maximum, first quartile, second quartile and third quartile data. By using descriptive analytics, we can summarize entire data, we can analyze the data easily by using visualizations. See here, total female students are 51.8% and Male students are 48.2%. We can analyze the performance of students in the test based on gender. The female math score mean is 63 and the reading score means 72 and writing score means 72. And for males, math score is 68, but whereas in reading and writing scores, they are far below than the female students. If you compare the math scores of female and male students have the higher score in maths. These are the math scores based on ethnicity. See here, who completed the scores has higher scores in their test, but the students who did not complete the test preparation course has lower scores. We can visualize the same thing by bar charts, writing scores of students based on parent level of education. Here is the box plot for math and writing score and reading score. This is the math score and this is writing score, and it is for reading score. In math, so many students with less scores. This is the box plot for math scores for males and female. See here, more female students failed in the maths, means they have very low scores in maths when it compared with the males. Like this, we can summarize our entire data by using descriptive analytics based on this kind of visualizations. This is the simple example for descriptive analytics report. Google Analytics for website and dashboards are good example for descriptive analytics reports.